Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed limits and derivatives introduction and we have solved first 15 questions from exercise 13.1. Hope it was clear for you all. In today's session, we shall discuss the remaining problems from exercise 13.1. Let's move on to the topic. Let's begin with question number 16. Evaluate the given limit x tends to 0 cos x divided by pi minus x. Here directly we can substitute the value of x as 0 because 0 by 0 form will not come. So when we write limit x tends to 0 cos x divided by pi minus x is equal to cos 0 divided by pi minus 0. X is replaced with 0. So cos 0 divided by pi minus 0, that is equal to cos 0 divided by pi minus 0 is pi itself. As we know that cos 0 is equal to 1, we can just substitute that value, that is 1 divided by pi. Reason is cos 0 is equal to 1. We have substituted that value. So the answer is 1 divided by pi. Move on to question number 17. Evaluate the given limit x tends to 0 cos 2x minus 1 divided by cos x minus 1. Here a little bit of calculation we have to do. Cos 2x we have to substitute. We know the formula of cos 2 theta. So limit x tends to 0 cos 2x minus 1 divided by cos x minus 1 is equal to cos 2x, there is a formula 1 minus 2 sine square x, that we have to substitute. Cos 2x is equal to 1 minus 2 sine square x minus 1 divided by cos x minus 1. Reason is we have used the formula cos 2x is equal to 1 minus 2 sine square x. Let's remove this bracket, that is limit x tends to 0 1 minus sine square x minus 1 divided by denominator is cos x minus 1. Here plus 1 and minus 1 can be cancelled and we will be getting the answer minus 2 sine square x by cos x minus 1. Denominator is having a cos term, so we can change this sign into cos by using the identities. Sine square x, we know the formula 1 minus cos square x. Let's substitute it. Limit x tends to 0 minus 2 into 1 minus cos square x. This sine square x we have changed as 1 minus cos square x by cos x minus 1. Reason, sine square x we have used as 1 minus cos square x. And there is a minus term in numerator common. So let's take a minus sign in the denominator. That is limit x tends to 0 minus 2 into 1 minus cos square x, that is the same numerator, but denominator we have taken as a minus common, that is minus 1 common. Minus 1 if you take out, it will be coming as minus 1 into 1 minus cos x. Just we have reversed. Then this minus and minus can be cancelled and this 1 minus cos square x, this is in the form a square minus b square, that we have to change. Limit x tends to 0, 2 into, this minus signs cancelled. 1 minus cos square x we can write it as a square minus b square form 1 square minus cos square x. As we know that a square minus b square, a minus b into a plus b, limit x tends to 0, 2 into a minus b, that is 1 minus cos x, into a plus b, that is 1 plus cos x, divided by 1 minus cos x. And the numerator there is 1 minus cos x, denominator also there is 1 minus cos x. Common terms we can cancel and we will be getting as limit x tends to 0, 2 into 1 plus cos x. This 1 minus cos x cancelled, both numerator and denominator. So 2 into 1 plus cos x. Now we can easily substitute the value of x. That is x is equal to 0 when we substitute 2 into 1 plus, here there is x. We can substitute x as 0, 1 plus cos 0. 2 into 1 plus cos 0 value is 1. So 2 into 1 plus 1. 1 plus 1 is 2, 2 into 2 is 4. So the final answer we will get as 4. Move on to the 18th question. Evaluate the given limit x tends to 0, ax plus x cos x divided by b sin x. This is the question. So here limit x tends to 0, ax plus x cos x divided by b sin x is equal to, little bit of arrangement we have to do first, because here denominator there is a sin x and the numerator there is one x common. First of all we will take that x common outside, that is limit x tends to 0. In these two there is an x common. If you take x outside, balance will be coming in the first term a and in the second term cos x. So a plus cos x divided by b sin x. Now this x and the sin x, if you bring together, we can use the formula limit x tends to 0 sin x by x. But here of course it is x by sin x form. First of all, let's separate it. That is limit x tends to 0. Here a plus cos x by b we have separated. When we separate this one, x by sin x will be coming as one term, x divided by sin x. Now this is not our standard form, or this is not our formula form. Formula form is sin x by x. So that means the reciprocal of this one. So we have to make the reciprocal. For making this reciprocal, for balancing this statement, what we have to do is we have to change this symbol. Division, if you change, sorry, multiplication, if you change to division, then we can change the reciprocal here. That is limit x tends to 0, a plus cos x divided by b. This division we are changing, sorry, this multiplication we are changing to division. When you change this multiplication as division, we will be taking the reciprocal of this one. Both will be same. That is sin x divided by x. Now we can take the limit separately. That is limit x tends to 0. This term a plus cos x by b divided by limit x tends to 0 sin x divided by x. Now this is in the standard form, and if you substitute here directly the value of x means 0, here we will get a answer, not in the 0 by 0 format. So let's apply the rule, that is limit x tends to 0 a plus cos x by b divided by, this will come as 1 because this is a formula. Limit x tends to 0 sin x by x is equal to 1. Now limit x tends to 0 a plus cos x by b, division by 1 is the same quantity itself, so a plus cos x by b. Now we can substitute 0 for x, putting x is equal to 0. A plus cos x is changed to 0, that is cos 0 divided by b. As we know, cos 0 is 1, a plus 1 divided by b we are getting as answer, a plus 1 divided. Next we shall discuss question number 19. Evaluate the given limit x tends to 0 x sec x. The question is limit x tends to 0 x sec x. Here the sec x value or the sec x term we have to change as a reciprocal form. That is, we know the reciprocal of sec x, that is 1 divided by cos x, that we have to change. Limit x tends to 0 x into sec x we are changing as 1 by cos x. That is limit x tends to 0 x into 1, that is x divided by cos x. Now directly we can substitute the value of 0 because that is not in the form 0 by 0, because cos 0 is 1. So this is 0 by 1 format it will come. So no problem, we can directly substitute. That is 0, when we substitute 0 divided by cos 0, that is equal to 0 divided by cos 0 value is 1. 0 by 1, that is equal to 0. So the answer is 0. Next is question number 20. Evaluate the given limit x tends to 0 sin ax plus bx by ax plus sin bx. A comma b and a plus b not equal to 0. So let's write the question. Limit x tends to 0 sin ax plus bx by ax plus sin bx. Here sin ax alone we have no use, and here sin bx alone also no use. So we know the formula, that is sin x by x. Here instead of x, ax is there. So we have to change this format as sin ax by ax, and here this one we have to change as sin bx by bx. Then only we can apply the limit formula. So here we need a denominator 1 ax, here we need a denominator 1 bx. Let's divide and multiply. That is limit x tends to 0. Here sin ax by ax, I put 1 ax here in the denominator, then multiply 1 ax outside. So when we cancel this ax, the same term sin ax will be coming. The remaining terms as it is, that is plus bx. Then here ax same. Here we need 1 extra bx in the denominator. We substituted that extra bx and we just multiply another bx on the numerator. Then limit x tends to 0 sin ax by ax, just taking the limit separately, into limit x tends to 0 ax plus limit x tends to 0 bx. That is what the numerator, and the denominator is limit x tends to 0 ax plus limit x tends to 0 bx into limit x tends to 0 sin bx by bx. By using algebra of limits we have distributed the limits. Then here limit x tends to 0 sin ax by ax is 1. and here limit x tends to 0, sin bx by bx also 1. Here x tends to 0 means ax also tends to 0. That's why it came as 1. So as x tends to 0, ax tends to 0. So limit ax tends to 0, sin ax by ax is 1. Here also same thing, limit x tends to 0 means bx also tends to 0. That means limit bx tends to 0, sin bx by bx is also 1. So these two terms will be coming as 1, means the balance will be limit x tends to 0 ax plus limit x tends to 0 bx, that is in the numerator. Denominator limit x tends to 0 ax plus limit x tends to 0 bx. This term comes as 0. Reason is here. As x tends to 0, ax tends to 0 and bx tends to 0 because x tends to 0. Ax tends to 0, bx tends to 0. That means limit x tends to 0, sin x by x is equal to 1. By using the formula, we change these two terms as 1. Then here, by using the algebra of limit, we can just we can take limit x tends to 0 as common one, then ax plus bx. Denominator also same thing, ax plus bx is separated and limit is outside. Now this ax plus bx, when we cancel, we will get as 1. That means limit x tends to 0, 1. It is a constant. Limit x tends to 0, a constant. That means the constant itself will be coming as answer. So the answer is 1. Move on to question number 21. Evaluate the given limit. Limit x tends to 0, cosec x minus cot x. Here the question is limit x tends to 0, cosec x minus cot x. First of all, we have to change this cosec x and cot x in terms of sin and cos. So cosec x, there is a reciprocal formula. Cosec x is equal to 1 by sin x. And cot x, there is a formula in terms of sin and cos, that is cos x by sin x. Let's substitute that one. Limit x tends to 0, 1 by sin x minus cos x by sin x. Here common denominator is sin x. Let's take the common denominator sin x. And numerator will come as 1 minus cos x. LCM we are taking here. Then just take this 1 minus cos x conjugate, that is 1 plus cos x, multiply it in the numerator and denominator, that is limit x tends to 0, 1 minus cos x by sin x into 1 plus cos x by 1 plus cos x. Now numerator 1 minus cos x into 1 plus cos x, a minus b into a plus b form. A minus b into a plus b is a square minus b square. Here a is 1, b is cos x. So 1 square minus cos square x divided by denominator, we can write it together, sin x into 1 plus cos x. Then limit x tends to 0, 1 square is 1, cos square x is same as it is. Then denominator is same, sin x into 1 plus cos x. As we know, 1 minus cos square x is sin x. By using identities, limit x tends to 0, sin x divided by 1 plus cos x. And here 1 minus cos square is sin square x. Sin square x and 1 sin x can be cancelled from the denominator. Numerator is sin square x, denominator is sin x. When we cancel 1 sin x, denominator sin x will be gone, and numerator there will be 1 sin x is balanced. That is what it is written here. If you want the step, you can add one more step here, or else you can just continue as it is. That is sin x divided by 1 plus cos x. Now when we substitute, we will not get it in 0 by 0 form. That is, when we put x is equal to 0, sin 0 divided by 1 plus cos 0. That is, sin 0 we know that it is 0, 1 plus cos 0 is 1. That is 0 by 1 plus 1. 0 by 1 plus 1 is 0 by 2. 0 by 2 is equal to 0. Move on to question number 22. Evaluate the given limit. Limit x tends to pi by 2 tan 2x divided by x minus pi by 2. Here when we substitute x is equal to pi by 2, it is in the form 0 by 0, because here tan pi divided by pi by 2 minus pi by 2 will be coming. That is 0 by 0 format. So we have to go for another alternative method. That is, we have to replace this x minus pi by 2 as some other variable. Let it be y. So y is equal to x minus pi by 2. Since here the limit is mentioned as x tends to pi by 2 and we have changed the variable as y, what change will take place with y when x tends to pi by 2? That is what we have to calculate. So when x tends to pi by 2, here x can be replaced and substitute pi by 2. That is, y tends to pi by 2 minus pi by 2, means y tends to 0. So y tends to pi by 2 minus pi by 2. As we know, pi by 2 minus pi by 2 is 0. Y tends to 0. This is the change. When x tends to pi by 2, y tends to 0. Then let's take the question. Limit x tends to pi by 2, tan 2x divided by x minus pi by 2 is equal to limit y tends to 0. Here, when x is changing to pi by 2, y is changing to 0. We are going to replace this variable x with y. Here, x we have to calculate. X means y is equal to x minus pi by 2. From here, x we can calculate. This minus pi by 2 bring to the left side. So it becomes plus pi by 2. So x becomes pi by 2 plus y. This minus pi by 2 comes to the left, means plus pi by 2. So tan of 2 into, this 2 remains same, 2 into x only changing. X is pi by 2 plus y divided by y. Now here there is a denominator 2. We can take it as common LCM. That is limit y tends to 0. 2 when we take LCM, pi plus 2y by 2 coming. So pi plus 2y by 2, denominator that 2 is there. Here also one 2 is there. That can be cancelled. That step I have not included. If you want, you can add, or else you can go for a mental calculation. Pi plus 2y by 2, denominator 2 and these 2 can be cancelled. So numerator will be only pi plus 2y by y. Now we have learned a formula in trigonometry. Tan pi plus x is equal to tan x. So by using that formula, limit y tends to 0, tan pi plus 2y. Pi plus 2y is tan 2y itself divided by y. This formula we have studied in trigonometry. Tan pi plus x is equal to tan x. That is what we have used here. Now tan we have to change into sine and cos. As we know, the formula is tan theta is equal to sine theta by cos theta. So here tan 2y is equal to sine 2y by cos 2y. Limit y tends to 0. Tan 2y we are changing as sine 2y by cos 2y. Denominator there is a y. We have separated as 1 by y. Now we can check here, sine 2y is there in the numerator, but denominator there is a y. But if you have a 2y here, we can use the formula sine x divided by x. Limit x tends to 0, sine x by x is 1. That format we have to bring. Then limit y tends to 0. First of all, let it take together. That is sine 2y and y we have to take together. And there is 1 by cos 2y is separated here. Sine 2y by y into 1 by cos 2y. Y we have separated in the sense we are going to make an adjustment and use the formula limit x tends to 0, sine x by x. But here denominator is having only y. If there is a 2, we can use the formula. For getting 2, what we have to do is just multiplying and dividing by 2 in the first term. That is limit y tends to 0. First of all, before applying that, let's separate the limit by using algebra of limit. Limit y tends to 0, sine 2y by y into limit y tends to 0, 1 by cos 2y. If you use the algebra of limit, then it will be easy for us to use the formula. Or else here itself we can multiply and divide, then later we can use. That is your choice. Then multiplying and dividing by 2 because we want an adjustment here. That is limit y tends to 0. In this term, we just multiply and divide 2. That is sine 2y by y into 2 by 2 into 2 by 2. Limit y tends to 0, 1 by cos 2y. And here, these 2 and y we can pair it. And these 2 we can take outside because it is a constant. That is equal to 2 into, these 2 came outside, 2 into sine 2y by these 2 together. That is 2y. This one no change, limit y tends to 0, cos 2y. Now this is in the form limit x tends to 0, sine x by x. Angle and the denominator is same. So angle is here 2y and the denominator is also 2y. By using the formula limit x tends to 0, sine x by x equal to 1, we can write this as 1. So it will be 2 into 1. This term becomes 1 into limit y tends to 0, 1 by cos 2y. Now it is in safe zone because when we substitute y is equal to 0, this is not in the form 0 by 0. Let's substitute it. That is 2 into 1 into 2 into 1 is 2 into 1 by cos 2y. When we substitute y is equal to 0, 1 divided by cos 2 into 0. That is equal to 2 divided by 2 into 1 is 2 divided by cos 2 into 0 is cos 0. As we know, cos 0 is 1. That is 2 by 1 equal to 2. That is the answer. Next, we shall discuss question number 23. find limit x tends to 0 f of x and limit x tends to 1 f of x, where f of x is equal to 2x plus 3 if x less than or equal to 0, 3 into x plus 1 if x greater than or equal to 0. From here onwards, we will go with a different approach, because here there are two functions are given to you and the set of values domain also it is different here. X less than or equal to 0 means x is smaller than or equal to 0 means we will use this function, that is 2x plus 3, and if x is more than 0 means we will use this function 3 into x plus 1. So from here onwards we will go with a different approach. Before starting solving this question, let's recall what we have learned while studying the basics of limits and derivatives. So in the first part of this video we have explained that limit x tends to 1, x square minus 1 divided by x minus 1, how we have calculated. We have taken values from 0.5 to 0.999 and we have found that the value of the function is approaching to 0. That means left of x, limit x tends to 1 is our limit. In that case we have taken left side of 1, that is 0.5, 0.9, 0.99 etc. up to 0.99999, and this is called the left of the limit, and here the right of the limit, because limit x tends to 1 is our given condition. So right of 1 is 1.1, 1.5, 1.01 and so on. And in both the cases we have found that the value of the function x square minus 1 by x minus 1 is approaching to 2. That is what we have discussed in the previous class. Means in both the cases, when we have taken the left hand side of the limit and the right side of the limit, in both the cases the value of the function is approaching to 2. Means both the cases the value is coinciding at 2. Then we say that limit x tends to 1, x square minus 1 divided by x minus 1 is equal to 2, we have learned. And this is what we have done there. 1 is our limit and we have taken the values from the left of 1 and we have taken the values from the right of 1 also. And this portion is called the left hand limit and right side portion is called right hand limit. And we have concluded like this: limit x tends to a minus f of x is expected value of f at x is equal to a, given the values of f near to the left of a. When we have taken the left of a values, we will write it as limit x tends to a minus. Left side we represent with a minus of f of x. This value is called the left hand limit of f at a. And another one what we have learned is limit x tends to a plus f of x is the expected value of f at x is equal to a, given the values of f near to the right of a, means these values, right side of a, here it is shown. And this value is called the right hand limit of f at a. And if the left hand and right hand limits coincide, we call common value as the limit of f at x is equal to a. Here both the values are approaching towards 2. So we have learned that limit x tends to 1, x square minus 1 by x minus 1 is equal to 2 in that case. Here we denote it by limit x tends to a f of x. This is a common notation. And this is the basics we are going to apply here. Finding the limit at x is equal to 0. Here this is the first question we are going to solve. Finding the limit at x is equal to 0. When we consider 0, there are left side of 0, these are the values, and right of 0, these are the values. And here limit x tends to 0 f of x, when x tends to 0 f of x, that is limit x tends to 0 f of x is equal to, these two values should coincide. Here it is mentioned coinciding at x is equal to a. That is what we have learned in the basics. That means left side of 0 whatever values you are taking, and the right side of values whatever value we take, means left hand limit and right hand limit should coincide. Then only we will be able to calculate this value, limit x tends to 0 f of x. That is limit x tends to 0, 0 minus means left hand limit of f of x, and limit x tends to 0, 0 plus means the right hand limit of f of x must be equal. Then we will be able to write limit x tends to 0 f of x. This is a concept we are going to apply here. So first of all we have to calculate the left hand limit, then we will go for calculating the right hand limit. Here left hand limit means limit x tends to 0 minus. This minus represents the left hand side. So left limit is limit x tends to 0 minus f of x is equal to left of 0 in the sense less than 0. Less than 0 in the sense here when it is x less than or equal to 0, this is the function you have to take 2x plus 3. That means limit x tends to 0, 2x plus 3. And in the right hand limit x tends to 0 plus means right side of 0, right hand limit. That is what this plus means. F of x is equal to when x greater than 0 means the right hand side of 0 means this is the function we have to use. That is limit x tends to 0, 3 into x plus 1. Now calculations as usual, that is limit x tends to 0 when 2x plus 3, that is equal to 2 into, let's substitute here x is 0, that is 2 into 0 plus 3. 2 into 0 plus 3 is 0 plus 3, that is equal to 3. And here when we calculate on the right side, that is 3 into x, when we replace with 0, 3 into 0 plus 1, that is equal to 3 into 1, that is equal to 3. Now you can see here left hand limit and right hand limits are coinciding, means they are same. That means limit exists. If they are not coinciding, we can conclude that limit does not exist. That also we have discussed in the first slide. That is here 3, both the side we are getting 3. So we can say that limit x tends to 0 f of x. Here there is no minus, no plus. Limit x tends to 0. It is explained here. So limit x tends to 0, f of x is equal to 3. We have checked the left hand limit 0 minus also we checked. Right hand limit 0 plus also we checked. Both are coinciding. So we can write limit x tends to 0, f of x is equal to 3. This is the answer of the first part. Then the second part, when we consider finding the limit at x is equal to 1. X is equal to 1 means it is clearly x greater than 0. Means here we are using only one function, that is 3 into x plus 1. So you can do the normal calculation. No need to go like this. Here limit x tends to 1 f of x is equal to limit x tends to 1. When x is greater than 0, the function is 3 into x plus 1. That is what we are going to take. Then when we substitute value of x as 1, that is 3 into 1 plus 1. 3 into 1 plus 1 is 3 into 2, that is equal to 6. So limit x tends to 1 f of x is equal to 6. Next we shall discuss question number 24. Find limit x tends to 1 f of x when f of x is equal to x square minus 1 when x less than or equal to 1 minus x square minus 1 when x greater than 1. Here also two different functions are given to you for different domains. So we have to use the left hand limit, right hand limit approach. Here the limit at x is equal to 1 will be limit x tends to 1 f of x is equal to limit x tends to 1 minus, mean left hand side limit and 1 plus right hand side limit should coincide. Then we will be able to calculate limit x tends to 1 f of x. Here let's calculate the left hand limit and the right hand limit. Limit x tends to 1 minus left hand limit of f of x is equal to, here when there is left hand side of f of x we take, that is less than 1. Less than 1 means x square minus 1 is the function. Left hand side limit in the sense here the limit is 1, x tends to 1 means left of limit is less than 1. X less than 1 is x square minus 1 function. So limit x tends to 1, x square minus 1. And the right hand side limit x tends to 1 plus f of x is x greater than 1 is the domain, that is minus x square minus 1. So limit x tends to 1 minus x square minus 1. And let's calculate here, that is when you substitute 1 here, 1 into 1 square, that is 1 minus 1. 1 minus 1 is equal to 0. And here on the right hand side limit x tends to 1 minus x square minus 1, that is equal to, here minus is there, this 1 value we substitute, minus is outside, you have to be careful, that is 1 square minus 1. 1 square is 1, 1 minus 1, that is equal to minus 1 minus 1, minus 1 minus 1 is minus 2. Now you can see here left hand limit we are getting as 0, right hand limit we are getting as minus 2. Both are not equal. So limit does not exist because they are not coinciding. We have to write the conclusion, limit x tends to 1 plus f of x is not equal to limit x tends to 1 minus f of x. Left hand limit and right hand limit are not coinciding. Therefore, we can come to the conclusion left hand limit and right hand limit are not equal. Therefore, limit x tends to 1 f of x does not exist. Next, we shall discuss question number 25. Evaluate limit x tends to 0 f of x where f of x is equal to modulus of x by x if x not equal to 0, and f of x is equal to 0 if x is equal to 0. Here, little bit of clarity we need to make this definition, that is f of x is equal to modulus of x by x when x not equal to 0. X not equal to 0 in the sense not 0 means left of 0 and right of 0, this function we can use. And when x is equal to 0, we have to use 0. When left of 0 and right of 0, when we are considering, we can use this function, and when x equal to 0, we will use this value. Okay. Then left hand limit and right hand limit we will calculate. Left hand limit is equal to limit x tends to here 0. So left hand limit is 0 minus of f of x is equal to 0 minus means left hand side of 0, that is this function modulus of x by x. So limit x tends to 0 minus modulus of x by x. And on the right hand side limit x tends to 0 plus f of x is equal to right hand side also we will use this function, right hand side of 0 also we will use this function because it is for x not equal to 0, modulus of x divided by x. Now we have learned the modulus function. F of x is equal to minus x if x is less than 0. If x is smaller than 0 means the value will be minus x, the function is minus x. And if x is more than or equal to 0, greater than or equal to 0 means we will take the positive x. So we will take the negative x when x is smaller than 0. We will take positive x when x is more than or equal to 0. So here 0 minus means it is less than 0. Less than 0 means we will change the function, that is modulus x value is minus x. Since here it is 0 minus. So limit x tends to 0. Here you can take this value, that is minus x. So minus x divided by x, that is limit x tends to 0, x cancelled, will be getting as minus 1, that is equal to minus 1 is the answer. Then when the right hand side limit taking time 0 plus means x is greater than or equal to 0, that means this value we will take modulus function, that is modulus of x will be changed as x divided by x. So x divided by x is 1. So limit x tends to 0 1, limit x tends to 0 1 is 1 itself. Here also you can see the left hand side limit and right hand side limits are not coinciding, that is limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus f of x. So we can come to the conclusion limit x tends to 0 f of x does not exist. Move on to question number 26. Find limit x tends to 0 f of x is equal to x divided by modulus of x if x not equal to 0, f of x is equal to 0 if x is equal to 0. This is somewhat similar to the previous question. So this question you will try it as homework. Next we shall discuss question number 27. Find limit x tends to 5 f of x where f of x is equal to modulus of x minus 5. So left hand limit and right hand limit let's calculate. Here left hand limit means 5 minus limit x tends to 5 minus f of x is equal to limit x tends to 5 minus only one function, that is modulus of x minus 5. Then by using the definition of modulus function, here minus x means when x is less than 0 we will take minus x, when x is greater than or equal to 0 we will take x. But here it is 5 minus means left side of 5. Left side of 5 is of course it is greater than 0. So we will take the value x, that is limit x tends to 5 x minus 5. This modulus of x will be changing as x because 5 minus means left of 5. Left of 5 means it is positive, that is x greater than 0. So we will take the value x. So limit x tends to 5 of x minus 5. Then this is the definition we have used, that is 5 minus 5. When we substitute x is equal to 5 we will be getting 5 minus 5, that is equal to 0. Then right hand side limit, when you take limit x tends to 5 plus f of x is equal to limit x tends to 5 plus f of x is modulus of x minus 5. Here also let's apply the definition, that is 5 plus right side of 5. Right side of 5 means greater than 0, that is x we will be taking. So modulus of x will be replaced by x, limit x tends to 5 x minus 5, that is when we substitute 5 here, 5 minus 5, that is equal to 0. Here both the side left hand limit and right hand limit are equal, coinciding. So limit x tends to 5 minus f of x is equal to limit x tends to 5 plus f of x, both we are getting as 0. Hence limit x tends to 5 f of x is equal to 0. Next, we shall discuss question number 28. Suppose f of x is equal to a plus bx if x less than 0, f of x is equal to 4 if x is equal to 1, f of x is equal to b minus ax if x is greater than 1, and if limit extends to 1, f of x is equal to f of 1, what are possible values of a and b? This is what the question. Here we are asked to find out the values of a and b in this expression or in this function. Here there are three expressions are given to you. One is a plus bx, that is x less than 0. X less than 0 means 0 left side of 0. If the value of x is less than 0, then we will take the function a plus bx. And if x is equal to 1, exactly at this position, if x is equal to 1 means we will take f of x as 4. And if x is greater than 1 means on the right side of 1, if you consider, you will take the function as b minus ax. This is what the explanation of these three values: x less than 0, x is equal to 1, and x greater than 1. Here the condition given to us is limit x tends to 1, f of x is equal to f of 1. F of 1 is, it is quite clear here, when x is equal to 1, f of 1. F of 1 we have 4. So the value of right hand side, that is f of 1, we know that it is 4. So here we need to find out limit x tends to 1, f of x. As before, we have to go for LHL and RHL. Then we have to find out the left hand limit, that is limit x tends to 1 minus f of x. Limit x tends to 1 minus f of x is limit x tends to 1, a plus bx. It means 1 minus is less than 0, left side of 0, that is. So a plus bx function we will take. Then limit x tends to 1 plus f of x. 1 plus f of x means right side of 1, that is limit x tends to 1 greater than 1 function you will take as b minus ax. Limit x tends to 1, b minus ax. Now let's substitute, that is when you substitute x as 1, it will be coming as a plus b into 1, that is equal to a plus b. And here will come as limit x tends to 1, b minus ax is b minus a. X is replaced by 1, so we will get as b minus a. Now it is given that limit x tends to 1, f of x is f of 1. Limit x tends to f of 1 means the left hand limit and the right hand limit should coincide. Means if these two should be equal, then only we can say that limit x tends to 1, f of x exists. Means limit x tends to 1 minus f of x and the limit x tends to 1 plus f of x. Since these two are equal, that equal value is equal to limit x tends to 1, f of x. That is equal to, according to the given condition, it is f of 1. Means simply if you say a plus b, that is limit x tends to 1 minus a plus b, and limit x tends to 1 plus f of x, that is b minus a, that is equal to f of 1. F of 1 we have 4. From here directly we can write f of 1 is 4. So we can equate a plus b is equal to 4 and b minus a equal to 4. Then we can solve by these two equations and we will get the value of a and b. Here directly we can add these two equations, that is a plus b minus a equal to 4 plus 4. Just adding these two equations, because when we add these two equations, a and a will be cancelled. So 2b is equal to 8, b is equal to 4 will be getting. Since one value we have got, we can substitute in any one of the equation, that is a plus b is equal to 4 I am considering. Substitute here value of b, that is a plus 4 is equal to 4, a is equal to 4 and 4 cancelled, a equal to 0 we will be getting. So here possible values of a and b we have got, a is equal to 0 and b is equal to 4. Move on to question number 29. Let a1, a2, etc. an be fixed real numbers and define a function f of x is equal to x minus a1 into x minus a2, etc. to x minus an. What is limit x tends to a1 f of x for some a not equal to a1, a2, etc. an? Compute limit x tends to a f of x. This is the question. So here a1, a2, etc. an be fixed to real numbers and define a function f of x is equal to x minus a1 into x minus a2, etc. into x minus an. So this is a function given to us. We are asked to find out limit x tends to a1 f of x first, and condition is given, and again limit x tends to f of x also we are asked to calculate. Very simple question. That is let's write f of x first. F of x is equal to x minus a1 into x minus a2 etc. into x minus an. Here first question is limit x tends to a1 f of x we have to calculate. Limit x tends to a1 f of x is equal to limit x tends to a1 f of x we have to put substitute, that is x minus a1 into x minus a2 etc. into x minus an. It's quite simple here, just replace x and put a1, that is putting x equal to a1 equal to, here when you replace x with a1, that is a1 minus a1, then here also replaced with a1, that is a1 minus a2 etc. into a1 minus an. X is replaced by a1, so no need of thinking of these numbers. First number itself 0, a1 minus a1, when you subtract these two will be getting 0, 0 into a1 minus a2 into etc. into a1 minus an. So 0 into any quantity is 0 itself. Next is limit x tends to a f of x, that is what we have to calculate, that is equal to limit x tends to a, again as before just substitute f of x, x minus a1 into x minus a2 etc. into x minus an. Same as the previous one, putting x as a minus a1 into a minus a2 into etc. into a minus an. That is what the expression, that is a minus a1. X is replaced and substituted the value as a minus a1 into a minus a2 etc. into a minus an. Therefore, limit x tends to a f of x is equal to, let's write down the answer, a minus a1 into a minus a2 into etc. into a minus an. Dear students, today we have discussed question number 16 to 29 from exercise 13.1, and there are different methods we have learned. I request all the students to go through these questions and solve independently. While solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.